12 and 20. Let's let that load up there. 1, 2, 3, go. There it is. Okay, you're looking for the largest number that goes into both. So the proper way to do this is actually to build a factor tree for each number. Have you seen this before, a factor ladder?
Yeah, I've seen something like this in my books.
Okay. Now, what you're looking for is what is the same in both. Do you see how there's a 2 in both? And there's yet another 2 in both? So the greatest common factor is 4. 4 is the largest number that goes into both.
Okay.
All right. And maybe you can see that, like some students can they're just like, oh yeah, it's 4. Or they try 2 and they realize it's too small and they say, okay, maybe it's 4. You do not have to make a factor ladder or factor tree, but you do have to come up with obviously the right answer.
Okay.
So whenever you're ready, if you want to send over or give me the next problem, we can look at that together.
Okay. So I guess I could just, it's in my book, so I could try to take a picture.
Are you able to email from your phone?
I believe so. Yeah, I don't have my dad's email, but I have mine.
Whatever you want to, you can send. It doesn't matter to me. I'm just going to send you Tutoring by Matthew stuff on there. Let me drop my email in the chat. It will be the most efficient way to do it.
Okay.
You can also reply to the booking email if you want to send stuff ahead of time. I'm happy to, you can fill up my inbox with whatever you want to work on. Doesn't bother me.
But I believe maybe I could just tell you because
Sure.
my phone is just 6x squared y cubed and then 12x cubed y squared 21x y 4.
Okay. Please confirm that what you said is what you're seeing on the screen.
Yep.
All right, so we look at first the numbers. Okay, first the numbers. So we're looking at 6, 12, and 21. And we're trying to find the largest number that goes into all of them. Can you tell me that number? 6, 12, and 20. Basically, I'm asking, can you kind of look at it and just be like, all right, I think it's that looks about right to me.
I would say 3.
Okay, I agree. It is 3. Now you next look at the x's. Okay, so you've got x squared, x to the power 3. What is the x power on the last one?
1.
1. So you use the one with the smallest power. So 3x to the 1. And then now you look at the y's and do the same thing. You've got y cubed, y squared, y to the 4th. Which is the smallest exponent?
Y squared.
Y squared. So this is what I've written on the left here is your GCF. Now my question to you is do you have to factor it or is it just to find the GCF?
Determine the greatest common factor. Show your work. Yeah, it's just determine the greatest common factor.
Okay. So there's not really like work or steps in this one. You could maybe build a factor ladder for the numbers. That's why I was asking if you have to show the factoring, because that kind of is showing your work in another way. But
yeah, it just says show your work, and that's it.
Yeah. So what you could do is maybe right off to the side, like x squared, x cubed, and x to the 1, and maybe just show that it's x, just like you did for the 6, 12, and 21. That's 3. Y cubed, y squared, y to the 4th. Say, okay, that must be y squared.
Okay. Yeah, that would work. Okay. So now So I want to do factor each polynomial completely. So they're short problems. So I'm just
Okay.
gonna
Okay.
give just okay. Yeah, I sent it.
All right. So we're factoring completely 4b plus 12. Is that right?
Yes.
All right. So you look at the numbers. What's the largest? What goes into both 4 and 12? Or the largest number that goes into both 4 and 12?
2.
Okay, so let's try 2. 2, and then you divide each of these by 2. What is 4b divided by 2?
2b.
Okay, and how about 12 divided by 2?
6.
Okay, now you might look at these and say, oh, actually, I can get another 2 out of 2 and 6. Do you agree with that?
Mm-hmm.
So you can do it from here, but it's probably better to go back to the previous one and say, okay, it should have been 4.
Okay.
And you write the 4 on the outside, and then what goes on the inside is 4b divided by 4, 12 divided by 4. So that's b
B
plus
B 4. Yeah. B3
plus 3. Plus 3.
plus 3.
I noticed when you said one of the other problems, you omitted the operators. They're very important.
Okay.
Very, very important.
Okay. Are you there?
Yes. So that's it. That's your final answer.
Okay. I was just waiting for you to say something.
Yeah, there's a little awkwardness over the Zoom. I sometimes I do mute myself and then I don't realize I've muted myself. So always just interrupt if you're wondering what's going on or ask me. I also try to take more pauses. I notice I go too fast, so I try to take a few breaths and just let this go. So what is the next problem you want us to look at?
Another short one.
Okay. Are you using an online system or is this in like a paper?
It's like my books. Like I have,
Books.
yeah. So
Cool.
I couldn't really send screenshots.
Got it. Yeah. No, I get it. Sometimes there's okay. So your greatest common factor, we were talking about this a lot during our first lesson. It's either a number or a variable or both. In this problem, it's just a variable. Do you see that there's an x in both of these?
Yes.
So you can factor out that x from both. And you're literally dividing both of these by x. Okay, so what goes in parentheses is the result of bx divided by x, which is b, and then 2x divided by x, which is 2. So in the previous problem, the GCF was just a number. In this problem, it's just a variable. The ones going forward will probably be both.
Okay.
The other thing here to point out is that if you were to multiply in, and it'll probably make more sense than the previous problem, if you were to take 4 times b, you get back to the original, and 4 times 3, you get back to the original. And that is always the case.
Okay. All right. We'll give, I'm just gonna say it,
Okay.
2x squared minus 6x plus 9.
Like this.
No, it's just x by itself.
So 2x squared minus,
Well, I meant x squared.
just x squared, like this.
Mm-hmm.
Okay. So this is no longer GCF factoring. This is not a GCF.
Okay.
This is a trinomial. Does that sound familiar to you?
Mhm.
Okay, so there's actually like 5 different types of factoring that you're going to see. One is a GCF. The second is difference of squares. These are my order, not necessarily the order you're going to see there. The next one is called a perfect square trinomial. That's actually what this one is. And then there's a equals 1 and a not equal to 1, which is grouping. So this is a perfect square trinomial. So how does Matthew know that? Well, you're looking for 2 numbers that multiply to 9 but add to -6. So do you see that 1 and 9 multiply to 9?
Yes.
Same with 3 and 3.
Mhm.
But what does 1 plus 9 add up to?
10.
10. And not only is it positive, we want -6. It's not negative. And same with 3 plus 3, that's 6. We want negative. So how do we get that? If you make them both negative, is -1 times -9, 9.
Yes.
And -3 times -3 is also still 9. Do any of these now add up to -6?
I would say the bottom one.
Yes. Okay. Now you still maybe wonder, why is this a perfect square trinomial? Do you see that those are the same values? It's a duplicate.
Oh yeah. Huh.
That's what makes it a perfect square trinomial. The fact that it's the same number
Mhm.
twice.
That's interesting. Okay.
Let
Are
me
you
know when
there?
you get, yeah, let me know when you get this down and we'll move on to another question.
Oh, okay. So, okay. I'll just, let's see, let's another long one or semi-long. X squared minus 4xy plus 4y squared.
Okay, good. This is another perfect square trinomial. And there's kind of a progression. We're kind of increasing the difficulty of these problems pretty quickly here. So if we have some time, I'd like to fill in some of those gaps for you. But I want you to first look at this without the y. Just ignore the y for the moment. Okay.
Mhm.
Now we're going to do the same thing we did in the previous problem. Look at 4, 2 numbers that multiply to 4, but they have to add up to -4. So can you tell me 2 numbers that multiply to 4?
2.
Okay, 2 and 2. Any others?
4 and 1.
1 and 4. Yeah, good. Now, these add up to 1 plus 4 is 5, 2 plus 2 is 4. They better add up to positive numbers. So if you make them both negative, they still multiply to 4, but now they add up to a negative number. So which pair here adds up to the -4?
2, a -2 and -2.
Good, very good. Okay, so just like before, it's going to be x minus 2, x minus 2. Do you see that they are the same? Again, they're duplicates.
Yeah.
Okay, now you might be wondering, well, hey, Matthew, what about that y? Yeah, what about that y? Well, you just sneak it in here at the end.
Oh, okay.
Now there's a bit more to it, but I'm not giving you everything all at once because it could be overwhelming. But this is the best way to do this problem. When you have that extra letter, just ignore it. Just say, I don't know how to do it. Let me do one that's like it without the letter.
Okay. Interesting. Okay. So, let's do a short problem. 4, are you ready?
Yep.
4a squared minus 9.
Like this.
Mm-hmm.
All right. So remember that list I started writing? And my handwriting is not great. I said greatest common factors, difference of squares, perfect square trinomial. Well, this one is a difference of squares.
Okay.
Okay, difference of squares. And a couple of points here. First is that there's only two terms. That's one reason it's difference of squares.
Mhm.
Okay. The other one is that it's actually subtraction in there. Okay. Now here's what you're trying to do. You're trying to figure out what squared gets you back to the previous line. Okay, and I think the number's easier. So like what number do you square to get back to 9?
Like what I would multiply?
Yeah, square means to multiply by itself.
Okay. I would say
Like,
1.
okay, so like 1 squared is 1. We want to get to 9.
Oh,
2
okay.
squared is 4.
So it'd be 3.
Yes, very good. 3. Okay, now the one on the left here is a little more complicated. Let's first look at the number here, 4. What number do you square to get to 4?
2.
2. And then to get back to a squared, it's just a.
Okay.
Is that okay what we've done so far?
Yeah.
Great. Now there's a formula here for difference of squares. A squared minus b squared. A represents everything that's inside parentheses. So in your problem, a is really 2a and b is really 3. Is that okay? Is that clear?
Mhm.
So this has the following form: a minus b, a plus b. So in your problem, big A represents 2a. So instead of big A, you're going to write 2a. Instead of b, you're going to write 3.
This seems
Instead,
pretty familiar.
you probably have seen this before. Instead of a, you're going to write 2a. Instead of b, you're going to write 3.
Yeah. Yeah. So we would have to.
This is the answer.
Oh, okay.
That's the answer. What's below it is the formula that you need to write down or have known for other problems.
Mm-hmm. Okay. All right. So let's do another problem. So
So just to be clear, Josh, I would recommend, like, and I don't know what else you have in mind today, but I mean, really, we should be like spending a healthy chunk of time on like difference of square problems, and then a healthy chunk of time on perfect square trinomial problems. Like mixing them up is not going to be good for your learning, but we can certainly keep going through whatever you would like. I'm just making a recommendation.
yeah, I
to
would
you.
rather learn each
Yeah,
of those steps so then I could understand myself.
yeah. But you tell me if you've got stuff like we have to get through today. Let's get through it, and with the time remaining, we can choose one to work through.
I don't have we can do it next session,
Okay,
but I
sounds
want to
good.
understand perfect squares and other things. And
Got it. So what's next?
maybe we can go through the you had GCF and then
Yeah,
the little list you had.
we've had GCF, but did we cover everything you wanted to do?
For the most part, yes, but I would rather like to understand those.
Okay, are you sure you don't need any more problems done? Because sometimes it's good to get those knocked out first.
They're sort of the same problems, just factoring on the meals, just like we did last.
Okay, so let's do a healthy session here. You know, a few problems here of difference of squares. So the difference of squares formula, I'm going to start again with that. You have to know this, you know, the way you know your phone number or your address. You just have to know it. Like roll out of bed and you know it. Okay. Now there's always two terms. There's always a negative in front. So let me give you an example. Really, really a simple example here. Let's say it's x squared minus 16, okay?
Okay.
The only way you can get this wrong is if you don't write it in the following form with the squareds. Like what number gets you back to 16? What number do you square to get back to 16?
Say 8.
Okay, so 8 squared means 8 times 8, which is 64.
Oh, whoops. Thought plussing again. That would be 4.
That's 4. And that's why we were doing this, because I really want you to step through it incrementally so you can understand. All right, now, in terms of this formula up here at the top, can you tell me what big A is in your problem?
X.
It is X. What about big B? What is big B?
4.
4. So you have to remember that. Okay, and sometimes it's okay to even write that out, to start. So, all right, A is X and B is 4. Now you don't write A minus B, you write X minus 4, X plus 4.
Okay.
Is that clear?
Mm-hmm.
Okay, so let's have you try one here. What about X squared minus 1? What does that become?
That would be, if that was X minus 1, X plus 1.
So sometimes it is the same number, but only in this case, and that's because it's really X squared minus 1 squared.
Mm-hmm.
Yeah, that is correct here. Okay. So let me, kind of as a side topic here, we talked about earlier, 1 squared is 1, 2 squared is 4, 3 squared is 9. How far up do you feel like you know the squares?
I guess, as I remember learning in school, to 12, I would say.
Maybe
To
12.
12.
Okay. And are you allowed to use a calculator in
I would say yes and maybe no, but I
that's
think
the
I
problem.
can. Yeah.
Okay. So here's another possibility. Sometimes they flip the order. So they go 25 minus X squared. But it's still the same thing. You still have to figure out what's squared minus what's squared. Okay. So in this case, it's 5 and X. And you still write it as the first thing minus the second thing, first thing plus the second thing. So can you tell me what goes in parentheses here?
Go 5 minus X,
Good.
and 5 plus X.
Very good. Any questions on that?
No.
Okay. So here's one for you to try. Let's say it's y squared minus 100.
Mhm.
Just give me the final answer, please.
Y minus, let's say 10,
Very good.
and then Y plus 10.
Very good. Okay, now we kind of saw this in one of your problems. We'll look at it now. 9x squared minus 4y squared. Now it can be the case that there's more than just a letter and a number. It could be a coefficient, could actually be more than one letter. But it's the same game. You have to figure out what goes in parentheses so that when you square it, you get back to the previous line there. Okay.
Okay.
So can you tell me what goes in parentheses to get back to
3.
9x squared? 3 for the 9. What about for the x?
Let's say just X.
Very good. How about the one on the right here?
2Y.
Very good. So again, you write it as a minus b, a plus b. Can you tell me what goes in?
2X minus 2Y. I mean 3X, and then 3X plus 2Y.
Good. And it doesn't matter. Like if you want to do the plus one first and then the negative one, that's fine. That's totally fine.
Okay.
All right. So here's one for you to try here. Let's go 40. 49 v squared minus 64 u squared.
Okay. Let's say 49 divided by 2 is 24.5.
We're not dividing. Did you divide? See, 9, you didn't divide to get to 3. What did you do to you? And you actually go the other direction. What are you doing to go from 3 to 9?
Multiply.
By itself. You're squaring.
Mm-hmm.
Right. So like, look, let's go back and look. See how 5 squared is 25.
Mm-hmm.
That's why I was asking for this list over here on the right, because that's what you've got to be really comfortable with. 4 squared is 16 and 5 squared is 25 and so on. So in this problem, you're that 49, you're not dividing it. You're finding a number that when multiplied by itself gets you to 49.
Oh, okay. So then, 7 v squared. Yes. Okay. 7 and then plus 64. I think that would be times 8. 8 u
What goes in between them?
plus
Okay. How about the other one?
7v minus 8u.
Very good. Very good. Let's have you do one more here. Just increase the difficulty a tiny bit. Let's go 81 p squared minus 121 q squared. And after this, we'll go to perfect square trinomials.
Okay. Okay. 9p plus 11q, 9p minus 11q.
Very good. Any questions on that before we move on to
No.
something else? Okay. All right, so let's talk about perfect square trinomials.
Okay.
All right. Are you in a classroom or are you in an online program?
I would say online.
Okay.
We order like DVDs so I can watch them at my own
Got it.
pace.
Got it. Okay. Yeah, because there's some sort of gap here, and I'm starting to see what that is. That's good. I'm here to support whatever you're doing for school. So perfect square trinomials, they have the following form: a squared plus 2ab plus b squared. And maybe that's overwhelming because it's like more letters, more stuff. But we've actually already done one. So let's look at one we've already done. X squared plus 6x plus 9. Okay.
Okay.
Can you tell me what A is and what B is?
X and 9. A is X and B is 9.
Okay, so take one more look at this.
Oh, 3.
Yes, 3. Okay. Now the top always factors into A plus B squared, or sometimes it's written as A plus B times A plus B. So in your problem, that would be X plus 3 squared, or X plus 3 times X plus 3. Do you remember me making a comment about the pairs, the duplicates?
Mm-hmm.
So that's what perfect square trinomials are. They have duplicates in them. So this thing I'm boxing in, you definitely want to get that down. That's really important.
Okay. Just grab that piece of paper. Okay.
All right, so we're gonna look at some problems now using that formula again. So the idea here is to figure out, well, what is A and what is B. We'll make them kind of very simple to start out here. Let's say it's x squared plus 10x plus 25. Okay, so what is A and what is B? And notice I'm writing them under the one that it is.
Sec, X is for A and 5 is B.
Okay, so this becomes x plus 5 squared, or you can write it as x plus 5 times x plus 5. Both should be accepted by your teachers or whoever's grading this. Okay, so here's one for you to try. X squared plus 16x plus 64. Can you tell me what this becomes when you factor it?
X, and then, yes, just. This would be x plus 8 squared.
Very good. Awesome. Okay. Good. Any questions on that before I kind of change this up and make it a little more difficult?
No.
All right. So there's actually two perfect square trinomials. We just looked at the first one. And here is the second one. What is different about the first and the second?
There is a subtract sign.
That's right. So the top one factors into a plus b squared. The bottom one factors into a minus b squared.
Okay. Get this down. Okay.
All right, so we've done a couple of the second type already, believe it or not. We were looking at a problem earlier like this, was x squared minus 6x plus 9. And again, like a is really x and b is 3. But because there's this subtraction here, you have to write x minus 3 squared. That was one of the very first problems we did in our lesson today. And again, notice that, and I'm going to scroll up here. It's really similar to this one, right? X squared plus 6x plus 9. The only difference is the plus.
The plus
versus
yes.
the minus. Okay, so you have to be on the lookout for that. So I'll give you a couple here to try. Let's say it's x squared minus 20x plus 100. Can you tell me what this factors into, please?
Okay. Oops. A minus 10. Subtract 10. Okay.
Very good.
Believe that's it. Yeah.
That's it. Okay, let's have you do one more here. Let's say it's I'll switch it up here. Let's say it's p squared minus 24p plus 144.
And let's see. Okay, this would be p minus 12.
Very good.
Okay. 12. Okay.
Okay, now again, kind of there's always like a little adjustment, as soon as you think you've got it, it becomes more difficult. So here's a new problem for us to look at that still is a perfect square trinomial. It's just got more to it. Okay. So this one is a perfect square trinomial. At some point, I'll talk about how to differentiate between them, but just know that this is a perfect square trinomial. So you have to figure out what squared gets you back to this and what squared gets you back to the previous one.
Okay.
And we did that with the difference of squares. This should look very familiar to you.
Where
So what do you square to get back to 16?
looking here, 4.
4, good. And anything else? What about for the x squared?
Just x.
And for the 25?
5.
All right. So now you can write this as 4x plus 5 squared.
Okay. 4x. Okay.
Is that clear?
Mm-hmm.
Great. Here's one for you to try on your own.
X squared plus should be 5x and then 11 minus plus 11 plus
Good.
11.
Good. Very good. Squared.
Squared. Okay. All right, I have everything written down.
Awesome. So now the only way that I can make this more difficult is to just switch up the form a little bit here. So here's one more to look at. We're basically done with perfect square trinomials. It's amazing how quickly you can get through this stuff, but make sure you focus on the sign here. That's where there's just a little difference.
Okay. Okay, yeah. This would be 6 squared. It would be 6v minus 11 squared.
Very good. Excellent. Let me see if there's any other types that we're missing. I mean, there's kind of like even yet another type, but that's probably sufficient for what I would want to cover with you. So there are other types of factorings. We've covered GCF. We've covered difference of squares. The next one was the perfect square trinomial. Is there another problem on your sheet there that you want us to look at?
Let me look at this. No, it just looks, as I'm looking here, it's just factoring polynomials completely. That's they really want me to do.
So this next type is a equals 1. I can give you some problems to look at.
I was thinking maybe we can do just a couple more problems here.
Do you want me to give you more of the difference of squares and perfect square trinomials?
I think maybe more so like problems I have in my book.
Okay.
I'll do just a little. Just get this down. All right. So I'm just gonna read it out loud. X squared minus 8x plus 12.
Okay, so this is that next type I was mentioning, a equals 1.
Oh, okay, okay.
So this
Good example.
yeah. Okay, the way to do this problem is you look at the last number here and you're trying to find two numbers that multiply to 12 but add to -8. So like 1 and 12, 2 and 6, 3 and 4. Do any of these add up to -8?
They don't add up to -8. But 2 and 6 would be 8.
That's right. So if these were both negative,
Mhm.
so if you turn them both negative, -1, -12, -2, -6, -3, -4, they still multiply to 12, but this time they add to
-8.
add to negative. So it becomes x minus 2, x minus 6.
It's 12. Okay, wow. That's our answer.
That's it.
Wow, that's pretty simple. Wow. Okay, so let's do a similar one. I'll read it out loud. X squared plus 7x plus 12.
Okay, very good. So you go to that last number and you find two numbers that multiply to 12, but they have to add this time to +7.
This could be tough. 12. That was 6. Oh, okay. 3 and 4.
That's right. So it becomes x plus 3, x plus
4.
4.
Wow. Okay, we can do, let's see how much time we have left. We have about 10 minutes. Or,
No, so the lessons are 50 minutes, so we got 3-4 minutes left.
oh, okay.
So
I think we could do one more problem
sure.
since we were going pretty fast.
Yeah, we actually get a lot done in these lessons. A lot of people are surprised, but we pile it on for we'll do as much as we can and then
Yeah.
keep going next time.
Yeah. Okay, so read it out loud again. X squared minus x minus 27. Oh, my bad. 72. For some reason, parents say I have dyslexia, so it's 27.
72. I was going to tell you that 27 didn't work. So -72. This one's the hardest one of the bunch that we've done. So -72 is the number we're focusing on, and you write whatever you want to write all the numbers that multiply to -72. So it's -1 and 72, 1 and -72, -2 and 36, 2 and -36, -3 and 24, 3 and -24, -4 and 18, 4 and -18, -6 and 12, 6 and -12. And then the last one here is -8 and 9, 8, and then -9. What do we want the numbers to add up to this time?
Just to 1.
-1.
-1.
Yes. So which of this grouping adds up to -1?
-1 and 72.
Well, these all multiply to -72, but which of these add up to -1 on this list on the right? So like for example, like you said, that first one, -1 plus 72 is 71. That's way too big. Is it clear what I'm asking or not?
I think so in a way.
So like in the previous problem, 3 and 4, do you see how they add up to 7?
Mm-hmm.
That's what we're looking for here. They have to add up to -1. So that will end up being this last one here.
Oh, okay.
Okay, so it becomes x plus 8, x minus 9. The hardest part about these problems is actually just making the numbers in the list.
Mhm.
All right. So
Mm.
we get that down because we're basically out of time for today.